Optimizing and tuning queries. This nugget is all about finding those queries that are causing bottlenecks in the system and then fixing them, which could mean anything from simple indexes to refactoring to totally rewriting the query. And these are the kinds of queries that can really wreak havoc on a system. Now, if we're responsible for the data access layer and we're building our queries in development, and say we have a query that returns 20 rows and takes 2 seconds, not a big deal in development, but imagine in production if hundreds of users are running that query, we're going to bring the application and potentially our database server to its knees. So we should optimize and tune the queries we're responsible for in our data access layer in the development phase. Now, with the advent of SQL Server reporting services and ad hoc tools, it seems like we keep getting users closer and closer to the data, and by doing that, we're opening up the door for more rogue queries to hit the system. So this is why it's good to have an active monitoring system in place. So when you do get a rogue query that's pulling back more data than it needs, joining more tables than it needs, we can identify it and then get with the user to show them how to properly design a query. So we'll kick this nugget up by going over the tools of the trade. The more of these tools you have in your skill set, the better equipped you'll be to identify and fix poor performing queries. So we'll look at the Database Engine Tuning Advisor, talk about execution plans, go over extended events, also talk about the SQL Profiler and DMVs. All great tools for tuning, optimization, and even identification. Then we'll jump into the Virtual Nugget Lab. I'll show you how to identify long-running queries and also set up that active monitoring system so we can get notified via an alert when a long-running query hits the system. Then we will take a look at how to optimize and tune queries. I wrote an absolutely terrible query that's huge and does a lot of work and is very, very poor on performance. So we'll look at the ways to optimize it using the Database Engine Tuning Advisor, for instance, and then we will rewrite it using some advanced query techniques. Specifically, we'll look at pivot, which is a great way to turn rows into columns, and then we'll also look at a common table expression and how to do recursive CTEs. We'll start by getting familiar with the most popular tools used for tuning and optimization. First up, we have the Database Engine Tuning Advisor, just a wonderful tool for both development and production. In the world of development, it can get us a great head start on our indexing strategy. In the world of production, it can help us tune those poor performing queries. And it's really easy to work with. We create what are called workloads. A workload could be anything from a SQL script containing a single query to a script containing a bunch of queries. It could be a trace, which we generate here from SQL Server Profiler, which could contain an entire day's worth of activity. It can also run off the execution plan cache. So we feed it a workload, it analyzes it against the target database, and it will suggest indexes, index views, or partitions, or all of the above. And not only does it suggest them, but it writes the transact SQL for us, which is a nice bonus. I'll show you how we can use the Database Engine Tuning Advisor when we get into the Virtual Nugget Lab. A couple of my personal favorite tools here for tuning a query is execution plans and turning statistics IO on. We've used both of these in previous nuggets, but the reason I like these so much is because they show us exactly what's happening under the hood. We can use execution plans to get visual feedback on the query path. It also suggests missing indexes, and we can use statistics IO to view disk activity. What you see is what you get when it comes to these tools, and that's why I like them so much. And we do have an entire nugget dedicated to execution plans. Understanding execution plans, what all the tasks are and what the tooltips are within those tasks can go a long way in tuning and optimization. And it kind of goes without saying at this point, but dynamic management views. There are a lot of DMVs that span all the different areas of SQL Server. SQL's always keeping tabs on itself, tracking this information. So it's just a great way for us to peer in and see the state of these different areas, and we can use it for performance tuning as well, finding missing indexes and such. We also have the Extended Events Profiler. This was introduced in SQL Server 2008, expanded upon greatly here in SQL Server 2012, and it's how we do event-driven monitoring, logging, and troubleshooting. It's very lightweight, it's built right into the database engine, and it's highly customizable. So this will be our tool of the future when it comes to event-driven monitoring. We also have our good old friend SQL Profiler. This tool has been around forever. It's been one of my personal favorite tools here in SQL Server, and it saved my hiney on both sides, the database side and the application development side, because it's just a great way to see how things are hitting the system. Not only that, but we could create these traces that would span, the entire day, and it would allow us to find our hotspots in the day when people were running queries, when those expensive queries were hitting the system. We could just mine for so much good information about how people and applications who are using our system. It's great. So we could create these traces, analyze them. We could also then replay these traces to see how they would work on an upgraded system or even work in an entirely different environment. Sadly, our good old buddy the profiler has been deprecated here in 2012. And when I heard that news, I cried for days. But it's okay. Those wounds have healed because I've learned how to use extended events, which are awesome, and they handle the event-driven side that the profiler did for us and the real-time monitoring side, which has been added here in 2012. And it's only going to get better as time goes on. And then on the replay side, we have distributed replay, which is far more robust than profiler. Profiler, you could run a replay on a single machine. Distributed replay, you can run it across many machines. So these tools were built specifically for their area to replace all of what SQL Server Profiler did for us. With that, I think it's about time we head into the Virtual Nugget Lab. We'll learn how to tune and optimize some queries and use these tools to help us get there. All right, so we're in the Virtual Nugget Lab. Let's bring up Management Studio. We have a new project, 19, that optimize queries. And we're going to start with identification. How can we identify a long-running query? Show you how to do that using a DMV, how to do it using extended events, and then lastly, we will create an alert notification so we can get an email anytime that a long-running query hits the system. So let's simulate a long-running query, and I've executed this a few times, but let's just do it one more time here so you can see. Let's say that anything over 5 seconds, that's going to be our threshold, 5 seconds. Anything over 5 seconds is going to be deemed a long-running query. This should take 6 seconds. There it is. It took 6 seconds to run. And like I said, I've ran that a few times, so you'll be able to get some good execution stats inside of our DMV. But to use a DMV, we can use exec query stats. This DMV returns a lot of good information about query execution, logical and physical reads, logical writes, execution count, the number of times that it was executed, total worker time, and total elapsed time. The elapsed time is what we're going to use in our where clause to say give us anything over 5 seconds. Also note that you can cross-apply this to the dmexec SQL text function, pass in the handle, that's a column available in our query stats here, and you'll be able to extract the actual text, the actual query that's causing the problems. So let's run this, hit execute, and there should just be one in there. And look at that, I've executed it. We've executed it 3 times total. Here's our total elapsed time. Here is the statement text. So this is just an awesome DMV to always keep on, you have handy in case you need just a quick way to identify queries that are taking a while to run. Just note that anytime you restart SQL Server, all DMV information is also reset. Now let's move on to extended events. We'll create our extended event using T-SQL, but I do want to show you here. If you go into the management node, expand extended events and sessions, if you right click on session, you can either do this by walking through a wizard, or you can do it manually just using the property pages by choosing new session. And here's where you'll set up all the information about the session. Here's where you will define your events. You can put predicates on your events as well. Here's where you'll enable your data storage, where it's going to pipe all that information out to. So first, let me just walk through Transact SQL, then we'll look at what it did here using the GUI. So we're going to create an event called long running query. We're going to trap for 2 events. We're going to trap for stored procedures that take longer than 5 seconds and SQL statements that take longer than 5 seconds. We're going to bring back SQL text and the T-SQL stack as fields, along with all the other base fields. And we're going to put a where clause here on the duration, which is a part of a field from the actual event itself. And then our target here, where we're going to pipe all this information out to, is just going to be an event file called longrunningquery.xcl. So let's go ahead and create this event session. And now if we refresh over here, we should see it. There it is. And we didn't start it by default. We can do that as well. Let's just go ahead and right click and we will choose start session. There it is. Now it's green and it's running. And if any queries hit the system that are longer than 5 seconds, it will get logged. Before we do that, I just want to show you how this looks in the GUI. So if we go to the properties here for our event session, you can see the first tab is just information about the event here. We just gave it a name. Here's the big one, events. What events do you want to trap for? And you can search here. We can do an SP underscore, and it'll show us everything that's associated with stored procedures. So since we already have SP statement completed, it's showing up over here in the selected events, and here are the other events associated with it. So once you get the events you want to trap for, and by the way, if you click on any of these, you can see the actual fields associated with that event and a nice little description of each of them as well. So we're doing SP, stored procedures, statements are done, and SQL statements are done. These will give us access to things like duration, and we can hit the configure button here, and it'll allow us to set up global fields that we want to include along with the fields that are local to the event, and this is where the T-SQL uh, stack and the text come into play here. We're adding those as additional global fields, and then we're putting a filter on duration. One of the fields that both of these return is duration, so we can say anything over than 5,000 milliseconds, which is 5 seconds. You can also set up your data storage, which is where it's going to pipe all this data out to. We're just going to send it to an event file. So that looks pretty good. Let's do this. Let's right click and choose watch live data. Here's where your monitor comes into play. So this is cool. Now we've got a monitor sitting right here that we can view. And if we run that query again, it should take longer than 5 seconds. And as soon as it does, it should pop up right here. So let's see if it does. Greater than 5. Hey, there it is. Look at that statement. So that was a SQL statement. That wasn't a stored procedure. That's why this event fired. And if we scroll down here, we should see the SQL text that we told to include. If we double click on it, it'll open it up. Check that out. So extended events are great because we can trap for literally any event in SQL Server you can think of. And then we can do things like this. Watch it live if we're doing immediate troubleshooting, or we can just have it logged to a file somewhere that we could consume later. All right, so far so good. So we've got DMVs to help us identify long-running queries. We have extended events to help us monitor in real time and log long-running queries. And what about notifications? What about automation? Well, here we're going to create an alert. An alert using a performance counter here, transactions, longest transaction running time. If we say this is greater than 5 seconds, it's going to send a notification to us via email that we have a long-running query. So let me create this alert first. And then we'll just go into SQL Server Agent. We'll expand it. Here it is. I called this Notify Long-Running Query. If you want to look at it here, it's just a SQL Server Performance Condition Alert. The object I used was transactions, and then the counter I used was longest transaction running time. This is in seconds. So we can say if this counter rises above 5, it in response will notify our DBA operator via email. And we have set up database mail in a previous nugget. So we'd have everything we need to get automatic notifications if any long-running query were to hit the system. All right, so those are all great ways that we can discover, identify, log, and even get notified when long-running queries occur. Let's move in here to tuning queries. So once we've identified our long-running or poor-performing queries, then it's time to tune them. The first thing we should always do is just look at it, analyze it. Is there anything in here that we could rewrite or refactor? And I can tell you just by looking at this that we've already got some poor design decisions in here, namely subqueries and derived tables. Those can be pretty bad on performance. And by the way, this query aggregates stats by learner, by course. The stats that we're aggregating here are the number of bookmarks, notes, and pauses from the Learner Nugget activity table. We do have a where clause on here, so that should help with performance a little bit, and it'll allow us to create some good indexing techniques. But we're going to say we want to see all the stats broken out by category. So let's just get a baseline here. Let's run this query against Nugget Demo DB. And this one shouldn't be too bad. A second to return 3,200 rows, not bad. But let's say that this was inside of a parameterized stored procedure, meaning they could pass in any category or multiple categories or no category and get all categories. How would that work? Let's run this without a where clause and see exactly what we get. We're going to be sitting here a long time. I think this takes at least a minute to run, if not more. So this is definitely a query that could be rewritten. And we will rewrite this when we get into our advanced query segments. But let's say that everything was fine with this query. It was structurally sound. There's nothing more we could do from a coding perspective to optimize it. What we would do then as next steps is analyze the execution plans for pain points, find missing indexes. We can use execution plans for that. We have a DMV for that. And then, of course, as a last resort here, we could fire up the database engine tuning advisor, throw the query at it as a workload, and see what it suggests. So first, let's just take a look at execution plans. Here you can do estimated execution plan to see what it thinks it'll use, or you can do the actual, which after it executes the query, it'll show us the actual plan that was used. So let's just highlight all this once again and execute it. And when it's done here, it'll pop up with another tab for execution plan. Here's everything. And right off the bat here, you can see missing index. This is always good. I like doing this for really quick. I need to index this query. I don't want to fire up the execution plan, create a workload and all that. Just want to do this as a real quick what's wrong with this query, what can I do to improve it, then this is a great way to do it, because you can get these missing indexes. You can right click on it then, and you can actually hit missing index details, and it'll write the code for you, which is really nice. Now, if you have an extremely large execution plan like this one, because it's doing so much, this little plus button helps navigate it. So now you can head down the tree here. But this would be a tough plan to consume because it's doing so much. So this right here would just tell me, you know what, we've got to find a better way to write this query. But essentially, look for warning signs. Here's one right here. That's a bad deal right there. And this is a bad thing too right here. Estimated number of rows versus actual number of rows. That means our estimate, the cardinality is off. So this is actually an execution plan that may not be a quality plan. And again, we'll look at how to decipher all this information in our execution plan nugget. But for now, just know that analyze these things, look for warning signs, and look for missing indexes. They can help you figure out what's wrong with your query. We can also use DMVs to find missing indexes, and I've got a cool one down here that not only discovers missing indexes based on the queries that were hitting the system, but also writes the transact SQL for us. So this uses missing index group, stats groups, and details to accomplish this. If we highlight this and hit execute, there is the missing index it's suggesting based on the queries that are hitting our database. So object name, learner nugget activity. Here's our equality column. So there's our key right there, nugget ID in action. Here's our included column, learner ID, and then some statistical information about the queries that are hitting this table. And we also get the kind of advantage that we would get by putting this index on that table. That's a pretty big advantage there. And then, as I said here, it'll actually write the index out, which is pretty cool. So DMVs are great for a lot of reasons. There's another one. Let's take a look at how to use the Database Engine Tuning Advisor. And we're going to take this query up here, and I've already stored it in all by itself into a SQL file, and toss it as a workload against the Database Engine Tuning Advisor, and we will see what it suggests. So let's fire it up. Let's head down to Start, Programs, SQL Server 2012. If we head down here to Performance Tools, there it is, the Database Engine Tuning Advisor. You can also see the SQL Server profiler down there. But let's fire this up. All right, so once it's up here, we can connect to our SQL instance. It'll automatically create a session for us here. And now we can give it a name. We can specify our workload. We can browse to a file. We can also choose a table, or we can use the plan cache. So let's choose a file here. And I actually have a file called query_dta that contains the query that we were just looking at. So we'll open that up. That's going to be our workload. And then our database for the actual analysis, let's just go ahead and choose tempdb. That's a nice safe place for all temporary processing. And now we need to choose the databases and tables to tune. So we're going to tune Nugget Demo DB. If we drop this down, the table that we want to tune here is Learner Nugget Activity. All right, so that looks good. You can also go into your tuning options and choose what to suggest. So as far as indexes go, do we want indexes and index views? Do we just want indexes? What kind of indexes do we want? And do we want to include filtered indexes? You can also choose your partitioning strategy, and you can also have it rechange the physical design structure if we wanted to suggest anything at that level. So this looks good. Let's go ahead and hit Start Analysis. This will take a second to run and analyze. So I'll let that run, and I'll be back when it's complete, and we can analyze the results. So that was actually really quick, and we can get a 41% estimated improvement just by adding a couple of indexes and statistics. And here's the cool thing. If you scroll over and you click on the definition, it'll actually write it out for you. How neat is that? So let's look at our indexes here. The first index that's suggested is just Learner ID and Nugget ID as a composite key for a non-clustered index. Keep in mind you can just copy to clipboard, but before you run it, make sure you change the name because that is one long unintuitive name for an index. The second index here, Action, Nugget ID, and Learner ID, another non-clustered index. So just adding these couple of things will give us a 41% improvement. You can get more detailed information over here in reports. We've got some nice tuning reports down here. Here's the statement cost report. Here's the statement detail report, which will show us the current cost of the statement is 70.59. The recommended statement cost should be 41.57. You can even get some index usage report to see what indexes were currently being used. Detail report just breaks it out and gives us a lot more detail. And then you can even get a nice table access report to see what tables are involved and then what columns as well are being returned. So the Database Engine Tuning Advisor is awesome. It's easy to work with, and not only can you get recommendations for a query, but you can get them for a bunch of queries, an entire workload, and you can also get some good metadata here, some good stats about your queries and your workloads. Now, the last thing I want to do here is show you how to totally rewrite our query. Now, let me show you something interesting with this query. What we're really trying to accomplish is getting good statistics by creating a crosstab or a matrix report where we want to take values that are in a column and turn them into actual columns where we can then get counts across each one of those values. To give you an example here, let's look at our Learner Nugget activity table. Here it is, and here is our action. So see, this is just a part of the data. So the idea here is that we want to use a pivot query to turn these into columns. Isn't that cool? And here's the problem that you see people that don't understand how to do this. I've diagnosed so many queries where people want to do that, they just don't know a good way to do it, so they end up with subqueries after subquery after subquery, and that's how you create a very poor query, like we did over here. So let's open up our advanced queries, and the first thing I want to show you is just a basic pivot doing exactly that. And look at, we're gonna rewrite that query in about a tenth of the code. But this is exactly what it's going to do. It's going to do that same thing. We're going to pivot and turn that action column into action data into an actual column per action. And then I'll show you how to do it dynamically, because the problem with doing it this way is that we have to physically specify which actions we want as columns. So if we have something that is adding actions every couple of weeks, then we're going to have to go and touch every query and every report that does this to update it. So that's why I want to show you how to do it dynamically, which is, as good as it gets as far as pivoting goes. So first, let me show you the end result, and then we'll break it out piece by piece. So let's switch to Nugget Demo DB and execute this. Here's the final result. Each one of those actions, the tally of those actions per course. I took learner out of it because it just makes more sense to see this at the course level. So there they all are, all their data. Now let's break this out, going from the inside and working our way out. So here is our raw data right here, our inner select statement. This is just going to get all the courses, all the actions, and then the count of each action for that course. So that's the raw data. The next thing we want to do is pivot on that data. We're going to pivot on, and here's where you'll have your aggregation. It's going to aggregate it up for each column that you pivot on, for each value, I should say, in the column that you pivot on. And then we're going to say for action in, and we're going to specify which columns we're pivoting on. Notice we're omitting volume and forward and rewind and all that, and just saying give us bookmark, note, and pause. And here, let me just highlight all of this and hit execute. And here is that raw data broken out, course ID, bookmark, note, pause. The rest of this, all this outer stuff, is just simply to join the course so we can get the title rather than the course ID. And there is, once again, is our final result. Cool, right? Now if we wanted to add volume into this, for instance, we could do something like this. Give us volume. We'd have to add volume up here then. And now we'll get volume involved. There it is. Isn't that neat? So pivoting is great because it allows us to turn rows into columns. But the only downside with doing it this way is, again, if we have more actions coming in, then we're going to have to touch every query that's involved. So this is why it's nice to use a little dynamic SQL to make the whole thing dynamic. So the whole thing holding back our initial query from being dynamic is right here. Our manual column list, both in our pivot and in our select list. So that's what we're going to aim to get rid of here in our dynamic pivot. So we're going to need to declare a columns variable to hold that dynamic list of columns, the query to hold our dynamic query, and then we need to generate that list of columns. So let's do this from the inside out here. Actually, let me show you the end result. We'll just print this. Print and columns, and let's highlight it, I'll execute it. So here's the end result. It looks like a T-SQL statement, right? And that's what we're aiming for, to get this into something that T-SQL understands. All right, so let's break this out from the inside out. First, this is just going to do a select distinct, add a comma to the beginning of it, and then quote it for safety there. So, right, that looks good. It's starting to look like a SQL statement. But the problem here is that each item is a row, and we have a comma that doesn't need to be there. The first comma needs to go away. So the first problem here is turning this all into one row, and we can do that using for XML path. Passing in a blank string will get rid of the XML. So there it is. So there's our one big string of columns. The only thing left to do to make this totally T-SQL compliant is get rid of that first comma. Well, that's easy enough. That's where stuff comes into play. Stuff at the first position, first character, nothing. So that'll just delete that comma, and the end result will be a T-SQL formatted list of columns. Now we can turn that all into a query, execute it, and check it out. Every single action is now its own column. And if somebody were to go into the system and add another action, they would just start showing up in these results. So that's about as cool as it gets, and that's a great way to use dynamic SQL along with pivot to get some nice looking crosstab results. And just to show you here, let's add a new action called new action. Execute it and run this one more time. And now we should get right here. There it is. New action. See that? Isn't that cool? Great stuff. Oh, the power of dynamic SQL. It's really, really nice. Now, the last thing I want to show you here is just a little bit on how to create a recursive common table expression. If you're not familiar with what a CTE is, it stands for a common table expression, and it's very much like a derived table, just a place that houses temporary results that we can write statements against. The big difference, though, is that CTEs can be self-referencing, so we can do some very powerful things with recursion that we cannot do with derived tables. And we've got a great opportunity to do this within our data, because if we look in the Nugget Demo DB here, we have this category table, which has a parent category ID. So this will allow us to create kind of a hierarchy of categories that belong to other categories, and we can see how deep they are nested. So we're going to create a recursive CTE to do this. The first thing we need to do inside of our CTE is first define it and define the output, category ID, category name, parent category ID, and then the depth of that category. Our initial query here is just going to get all of the root categories. So these are going to be the parent categories. Then we're going to union together all of the other categories along with their depth. And this is the recursive part. Because we are referencing itself, it's going to join to itself until it's all the way as deep as it can go within our tree. So we set up our recursive CTE, and then we set up the actual query that is going to use the CTE and get the results, in which they will look like this. Here is our root levels, then all of our other levels, and right now we only go one level deep. So all of these belong to a root. We do not have a category that belongs to a subcategory that belongs to a root, but we will change that. So right now everything's either 0 or 1 as far as the depth goes. Now let's say that we did want to support categories within categories within categories. Let's add some more categories here. We'll add SQL Server to the Microsoft category, then we'll add SSRS to the SQL Server category, and then we'll add a couple of SSRS categories within the SSRS category. All right, so let's do that. There we go. Those are all in. And now we can do this one more time. We should, this time, as we scroll down, see more levels. Look at that. So SQL Server belongs to Microsoft. SSRS belongs to SQL Server. And you can see this by looking at their parent category ID. But this is the recursion part right here. It is giving us the depth of each category. Great stuff. So you can see CTEs just give us a much cleaner and consistent way to represent and navigate hierarchies within our data. In the CBT Nugget, we learned how to optimize and tune queries. We started off by getting familiar with the tools, such as the Database Engine Tuning Advisor, the Extended Events Profiler, talked a little bit about execution plans, DMVs, and even the SQL Server Profiler, which is getting deprecated here in this version. We then jumped into the Virtual Nugget Lab, where we saw how to identify long-running queries using DMVs, also using extended events, and even how to set up an alert to get notified of those long-running queries. We then saw how to optimize and tune a poor performing and poorly written query by using the Database Engine Tuning Advisor, execution plans, and DMVs. We finished it up by looking at some advanced query techniques, where we covered the pivot statement and also saw how to do recursive CTEs. I hope this has been informative for you, and I'd like to thank you for viewing.